Hi, and welcome to MSc. In this video, we're going to look at factoring simple trinomials. When we talk about simple trinomials, I don't mean necessarily that the process is simple, although once you get the hang of it, it will become easier for you. But I mean simple in that it's factorable over the integers. We're not going to have to do any huge trickery, and we don't have to use fractions to be able to factor these. So we're going to work through two examples here. And the first one, we'll notice that there's a coefficient of 1 on the front of that x squared. And so there's nothing to common factor. I can't common factor this. And so I'm going to jump straight to my trinomial factoring. And we know that we're going to set up two brackets, x as the first term in each bracket. And we're looking for two numbers that are going to go in to complement in as a second term in each bracket. Now what we do here for these is we look at the negative 16 that's here, and I'm looking for numbers that will multiply together to produce negative 16, and then I look at the coefficient on the x, that's negative 6, and I'm looking for numbers that will add to produce negative 6. And so I suggest to students as they're learning this skill, or if they struggle with this skill a bit, to quite literally list out factors. And I wouldn't worry about the negative at this exact moment. I would just look at 16. What are some factors of 16? Well, 1 and 16, well, that's not going to add to 6. We can have 2 and 8. Okay, well, that would add to 10, but if one of them's negative, it'll add to 6. So we have to think about which one would be negative in that case, because one of them has to be to multiply to negative 16. Well, if it was negative 8 and positive 2, if I added those together, then that would give me the negative 6. And so what that means is we can say that the values that go in are positive 2 and negative 8. And of course, you can try, and I encourage you to try foiling this back out, and you should get the same answer as above. And so you can always kind of do a double check on these. You can also double check them with technology, with a graphing calculator, graphing this function and this function, if they were a function y equals or f at x, or you could enter them into Desmos or an online graphing tool to check that you've got it correct. Okay? Let's move over to the other example. This one is slightly more involved in the fact that we have to common factor first, because I see a coefficient of 2, and not only that, but what makes this one a little bit easier than some other examples that you'll eventually encounter is that 2 is divisible into each of the numbers I see. So that means I can common factor out the 2. And that's going to leave me with x squared plus, I'm not going to change my sign because I didn't take a negative out. I'm going to keep my x, and 18 divided by 2 is 9. So 9 times 2 is 18. You can kind of do a double check as you go. Okay? And then half of 72 is 36. So 72 divided by 2 is 36, or 36 times 2 is negative 72. So now we have the quadratic here with a b value here and a value here. And again, what we're trying to find are numbers that are going to multiply to produce negative 36 and numbers that are going to add to produce positive 9. Okay, so again, I would suggest for students that are just starting out with this skill, I would strongly suggest that you just start listing the factors. So 36, well, 1 and 36, but there's no way we're going to add to 9 with that. I know one of them has to be negative as well, because the negative up top. I could have 2 and 18. That's not going to work. Does 3 go into 36? Oh, 3 does go into 36. 3 and 12. Ooh, and they can add to make a 9 if this was the negative and this was the positive. Right, positive 12 minus 3 is positive 9. So we can move back over to our answer here, and we can set up our brackets, and then we can say, well, this is going to be x minus 3 and x plus 12. Okay? And what this allows us to do in factored form is be able to potentially solve for the roots of the quadratic and work with the quadratic in a different manner. And perhaps this would be easier to graph because you could plot the x-intercepts and do some other work in that manner. So factoring is an essential skill for simplifying quadratics and even beyond into rational variable expressions as well. I hope this quick run through of some simple trinomial factoring has been helpful. As always, thank you very much for listening and watching.